Hello, it's Cyber here. Today I wanted to show you a Minecraft calculator I made. Well, one of the first projects I've actually made in creative mode. And has a few different components. Over here we have the input system, which has numbers ranging from 0 to 15, because it's a 4-bit calculator. We have an input selector. You can switch between input A and input B. Then we have a function selector. We can add two numbers or we can subtract two numbers. We have a 7-segment display for the outcome. And we have a binary indicator for both numbers. So going from 1 to 8. You might ask, how does this calculator work? How can this be? Well, I've color-coded some of the components in the machine. I shall start with the input. This big blue block is a input converter. So it converts the input from 0 to 15 to a 4-bit binary signal, which are the 4 blue lines here. And these signals go into one of two memory slots. One for A, these 4, and one for B, these 4. Gray blocks here, they're the memory selector. So these allow me to choose from memory bank A or memory bank B. For example, if I write 15 to memory bank A, you see all bits in memory bank A flip. And that's because when I push the button, the signal from the button goes to the gray part here, which goes all the way through here to the right part. And this right signal goes to memory slot A. So when the signal is active, the 4-bit signal, it gets written to the memory. Same thing for B. If I switch my setting to memory slot B, if I press a button now, it will write in the memory B cells. So for example, 5. So 1 plus 4 is 5. Now all this memory output gets routed to two different parts by this giant black mess of, it's quite messy. Yeah, my busing wasn't ideal for this project, but the first part of the busing goes all the way through here and then back to the top, and it displays the state of both memory slots. So you can see the closed zone. Second part goes to the most important part in the calculator. It's the ALU, this white part here. ALU stands for an arithmetic logic unit. And what it does, it can perform different functions given several inputs. For example, add two numbers together, so two bits. And it works much the same like a like you would add two numbers in a regular sheet of paper by carrying numbers, but on a base 2 scale. Now for subtracting numbers, I've included a converter because the system works on a 2-bit complement negative system. And by adding another adder here, I can convert the complement to the correct negative number, which we use. Now the output from both adders can be selected using the function key, the subtract or add. And then the resulting 4-bit signal goes into this giant binary converter, which converts it to one of 16 states, 16 rows here. And these 16 rows, they operate the segments in the display.